Welcome friends, welcome to today's session. I am Naveen Kumar. Let us understand about advanced technologies in concrete. Recently I had been to one of the seminars by IIT professor, and I heard one very interesting sentence there, that present concrete is not as your father's concrete. That has shocked my mind. What do you mean by father's concrete? That means concrete is the present concrete technology is changed drastically like anything. So what has changed? Why he has used that word to us, that present concrete is not like as your father's concrete? I thought I'll make this as a session with you guys, and I would like to disclose or share some of my views over those words. Let us start with today's session with advanced technologies or advanced era of concrete. Let's start. Friends, you can see in the screen that the development, the need of the concrete worldwide is increasing like anything. When you say increasing, the need of cement, the need of concrete, India is holding second position as of now. But if it continues like this, by mostly by 2050, we'll be crossing our competitor of China, and will become a largest concrete producer and supplier in the world. You can see in the screen green or blue sees that entire world is, we are competing with in the entire world, not with only one or two countries, right? What is required for a concrete? We require obviously aggregate, cement, and water. But using only aggregate, cement, and water, can we achieve? Is it really achievable using only these three? No, because as I mentioned, now the need is different. Now we want concrete must perform as per our designed requirements. We cannot design our project as per concrete technology. We will design the concrete as per our requirement. So concrete should listen, concrete should fulfill our technical requirements for the projects. So what are the technical requirements, or you can say behavioral, or you can say functional requirement of the concrete nowadays? It should flow like water, it should set on demand, it should gain strength when I want or on my demand, it should have infinite durability. We cannot design our concrete structures for say 50 years or 100 years, right? For us as a designers, as a concrete technologists, the concrete should perform for infinite durability. It should look evergreen and fresh every moment, because less maintenance is required, no wear and tears, right? It looks like it must look like a ever green, ever fresh always. And of course, last but not the least, it should have a low cost as well as less maintenance. And this is what is requirement or a need of the day. Correct? As we all know, there are many type of admixtures are available in the market. Out of that, and admixtures are meant to perform the concrete as per our requirement or our specifications or our performance based design, right? So as I mentioned, There are many available admixtures and chemicals are available. The laundry list I can explain here, like coloring admixture, bonding admixtures, grouting admixtures, germicidal or insecticidal admixtures, storing and dispensing admixtures, corrosion inhibitors, shrinkage reducing admixtures. There are some densifiers, what we call as, to increase the density of the concrete. That is mineral admixtures, microfines, nano additions. And also there are some additional additives as fibers, integral waterproofing admixtures. So there are variety of admixtures available in the market. But nowadays, as you may agree with me, we mainly focus on naphtha base, which is called as SNF, sulfonated naphthalene formaldehyde, and polycarboethers, PCE based admixtures. Yes, for performance based design, we may have to go many times. We may have to go with sulfonated melamine formaldehyde, that is SMF, acrylic polymer based AP, copolymer of carboxylic acrylic, sometimes CAE, sometimes CLAP, that is cross-linked acrylic polymer, multi-carboxylate ethers. It's just next version of polycarboxylate ethers, and obviously polyacrylates. So these are all waiting for you in the market. But what we do, we stick to our traditional way of concrete, that is SNF, naphtha based, because it's much cheaper in the market, right? Many things. You will agree with me that almost 50 to 60% of Indian contractors, whoever has set their batching plant inside the project site, they generally follow this SNF based mixed design because it's cheaper. The reason, sir, it's just hardly 10 minutes on from plant. The site is. Why to waste money on PC base and all, right? I'm just giving the example. Then why PC base? If you go with the PC base, what will happen? A well mixtured buttery mixture. Generally, our civil language we use it at site. Buttery mixture, right? Buttery mixture we get very good mixture, and sometimes if you go with the higher strength or higher grade of concrete, the concrete will be looks like a semi SCC, semi self compacted concrete, which looks good, less maintenance, less headache, right? Because no segregation, no bleeding. Obviously depend upon the mixture, but if it is mixed in a proper condition, it will behave in a good shape. Now sometimes we may go with combinations of these admixtures. Sometimes we go with combinations. Many times it will be for SCC, viscosity modifying, along with this retarders. Sometimes retarder with water reducer, right? So sometimes we mix with admixture, PC based admixture, or mid PC or mid range PC or low PC with fiber, or with sometimes we go with densifiers with using microfines. We go with modifications or mixings, right? So this happens, and this is the requirement of the project nowadays to achieve the performance based concrete. What is performance based design? Performance based design means the concrete or any work should be designed as per or as to perform as per my requirements. I should not be limited to its prime properties. I should be able to make concrete work like my requirements. It should perform as per my requirement. So what is the prime requirement of the designer or architects? It should be easily formable. Formable means the form work or everything should be easily done. Placing ability, right? It should be easily placed. We don't want many areas or congested areas and all, right? And then speed. There should be a speedy placement also. We cannot wait for one or two vehicles to wait, or 10 minutes, 20 minutes. We cannot do like those. We want a fast work. We don't have time nowadays, right? Then durability, as I explained, it should be an infinite durability of the concrete. These are the material perspective. What should be a structural performance, a structural perspective? Yes, it should hold a seismic, a wind, and extreme events which are happening periodically. Should hold that also. What are the material level challenges? We saw site level challenges. We saw the design level challenges. Now, what is the material level challenges? Material level challenges are nothing but our workmanship challenges. Work level. Like, can you expect, being a professional QC people at site, ever you not faced the tampering of concrete or adding water to the concrete? How can you maintain the viscosity of the concrete? That is why, as a QC, we always force the construction team to not to add or not to tamper the concrete which is mixed from plant, because it has been mixed, it has been designed for the performance. If you tamper it, if you change its quality, if the in rheology, it will not work, it will not perform as per our requirement. So what are the challenge is to keep the required flowability and to avoid the segregation. How if the reinforcement congestion is high, it is very difficult to avoid the segregation, because slurry will go in the gaps whichever it can flow, and aggregates will either remain there or they will fall down at the starter level, right? So how to avoid this situation, how to maintain this situation? Definitely, again, the admixtures are here to rescue. We have water reducer admixtures, we have viscosity modifying admixtures, microfines, and retarders. If we mix it properly with proper care and calculations at the plant, we might not face any need to tamper or add water or add a mixture at site. Many of my friends ask me this question, that Navin sir, can you explain that whether admixture at site can be added? Let me clear this doubt here, that any material which is fabric manufactured in a plant cannot be altered at site. Now you take in any ways. Once it is manufactured, it is manufactured. The only way you can make it again in a good shape, which is impossible, that you have to put that mixer back in the plant and mix it whatever you want again and get it back. Can you do it? It's not, right? It cannot be. So believe me that concrete, once it is mixed at the plant, don't touch it. Either you use it or discard it. Don't try to modify it at the site. Many people say that, Naveen, we have option of 2%, we have only used 0.5%, we have a chance of 1.5% more, we can temper it at site. It is not going to work. There is a reason. If you see the shape of the concrete carrying truck, the moment you pour the additional, whatever it is, you pour either water or admixture mixed with water, the moment you pour, it will not flow more than 1 meter from the mouth. This is the answer. And if you mix it, it is only going to mix that first 1 meter. And friends, in India, we don't have, at present, we don't have concrete transit mixers. We have concrete agitators, which have a blade inside in a spherical way, which will only keep concrete agitating till it reaches to the site. It will not mix in the site. I'll share the photos in this slide. What is concrete carrying truck or agitators and what are the transit mixers look like? Try to understand. So don't try to use agitators for a mixer, and mixers, obviously mixers are different, but don't try to use agitators for a mixing of concrete. They will not mix. So if you are thinking that, oh, I can add the water, I can there may be a provision in SPs and IS. There may be provision. I'm not denying it. The provision is meant in a standard condition, not for agitators condition. Try to understand the concept here. When I say performance-based concrete design, we heard about the material aspects, right? We heard about the material aspects, that it should flow, it should formability, it should have good durability, right? Performance-based design. But you should not neglect that nowadays the complex arrangements, complex detailing by the great designers and architects. I don't have any kind of negative thoughts about them. They are doing an excellent job for our society, our industry. And they design the structure requirement in such a way that sometimes it becomes very difficult for a site construction team to fulfill the requirement. You can see the picture here. It shows the typical congestion in reinforcement structures. I believe that there was no any other option for designer to choose this. Definitely he might have checked something before giving this kind of complex reinforcement structures. But designer should always, I personally believe that as a designer, one should always consider the workability at site also. As a QC person, I always expect the designer must have a round before starting of the concrete. He must have an inspection. I don't say a formal inspection procedure and all, but as these concrete structures are primarily dreamed by a designer or architects, the designer or architect become a primary owner to see the upcoming fulfillment of his dream or visualization. So I always emphasize on this aspect that any designer, any architect must visit the critical elements of concrete structures before they are cast. You see the reinforcement congestion here. And just imagine if we don't have performance based flowable concrete, or say in other words self compacting concrete, what and where how we'll end up in this. Once we open up a beautiful honeycomb, or say pockets, which looks very worst and which will be definitely resulted in NCRs. Do we require this? A contractor can just, a designer or architect can spare hardly half an hour or 1 hour to verify whether all workable elements are covered. If it is not workable, designer can propose an alternative solution immediately so that many mishaps can be avoided. Right? Now let us see the rheology of the concrete. I again repeat that I am not good in chemical part of this concrete technology, but I would like to share the overview picture of this rheology. In my view, what does this rheology means? Rheology means there are four simple concepts, aspects of calculating the rheology: stability, compactability, flowability, and cohesion. How the stability will come? When we avoid segregation and bleeding. How compactability will come? When we have a good density in the material. And how the cohesion and flowability will come? When we have a good viscosity and we have good internal friction. Correct? So in my way, this all entire mixture is called a rheology of the concrete. Now many of my BSc or lab hardcore concrete technologists may go into the deep by going a chemical composition formula and all. But for me, this is the overall picture meant by rheology of the concrete. So designer requirement is must here. Designer must come and show his existence to check his dreams or his visualization is getting true or is becoming true in the project. This is a small part of presentation I tried to cover today. We'll come up with next sessions in the future with more and more interesting topics. Till then, keep subscribing, keep sharing, keep commenting. Bye bye.